Hi, I'm Z from Google Research. Today I'm going to talk about coupled gradient estimator for discrete latent variables. This is the work done by myself, Andrew, and George from Google Research and DeepMind. Please check out our full paper on the archive as well as NeurIPS 2021. In sparse computation, variational inference, and reinforcement learning, it is often required to fit in models with discrete latent variables by optimizing the following training objectives. The gradient of this objective with respect to its model parameter theta is of the following form, where the second term can usually be estimated with a single Monte Carlo sample, and the first term with Monte Carlo estimations is usually of high variance. How to construct a low variance and biased gradient estimator for the first term is our focus. Following the previously proposed gradient estimator, which is called reinforced Lee-Van-Alt, which is of the following form, we apply the importance samplings and construct our gradient estimator, which is called disarm IW, where IW standing for importance weighting, where the weighting term is of the following form. To reduce the variance of the estimator, we can use a coupling distribution PZ and Z tilde to emphasize the term that has non-zero magnitude and jointly sample two coupled categorical variables Z and Z tilde. So by observing these gradient estimators, we can see that suppose two coupled categorical samples Z and Z tilde are equal to each other, we will have this particular term to be cancelled. Then the gradient estimation will be 0. So to have an efficient gradient estimator, we want to prevent this redundant situation. And by observing the denominator, we can see that suppose we have Z and Z tilde not equal to each other, where the numerator is non-zero, we want to prevent the situation where we have the coupling distribution to have zero mass. So we want to put non-zero mass for all the situations when the coupled samples are not equal to each other. So those two are an ideal property we want to maintain for a good couplings. Disarm IW, which is a proposed estimator, will reduce to disarm and U2G in the situation of a binary and with antistatic couplings. So a natural extension to the disarm and U2G is that we can use the antistatic binary samples to construct the categorical samples. The way to do that is using stick-breaking constructions. As you can see here, we have a sequence of 4 binary latent variables, and we can use the stick-breaking to construct a categorical variables with 4 categories. In addition to the importance sampling estimators, which we proposed previously, we can also directly apply these reparameterizations to the problems and in terms of the binary variables to construct the categorical samples, and then applying disarm or U2G on those categorical samples. Then we will reach a different version of gradient estimators. So this way, we will get a gradient estimator, and which is a natural extension of disarm using the categorical samples, but the construction of the categorical samples is using a sequence of binary variables with stick breaking. But instead of using stick breaking, we can use tree structure stick breaking, which is of this following form. And then we can reach a third gradient estimator, which we call a disarm tree. So overall, we will have 3 different versions of gradient estimators, and we hope all of them could improve upon the strong baseline, which is reinforced Lee-Van-Alt. So we evaluate all these 3 gradient estimators on 3 benchmarking datasets: MNIST, Fashion MNIST, and Omniglot. Here we show 2 of them. To view full detail, please check out our full paper. And here, we evaluate the gradient estimators on categorical VAE with 32 latent variables. Each one of them is of 64 categories. And you can see the proposed estimator will significantly improve the reinforcement Li-1 baseline. So please check out our full paper. And over there, we will have a derivation of the 3 estimators, as well as a multi-sample version of all of them, and its experimental comparisons against the reinforced Li-1, as well as its multi-sample version. Thanks a lot.